Hi everyone. We're going to be looking at functions now. I know we just started looking at C in general, and I know I'm throwing a lot of stuff at you, but I wanted to hit functions, sort of briefly go over them, do a couple more programs, and then we'll finally again look at some more examples of the other types of data and how your programs are working. At some point in time, there's just too much to go over in a new language to cover all. There's always got to be some starting step. And so we are covering functions now, but we might cover printf statements later on, or just soon. We will probably do some arithmetic next after that. We have to cover some topic, and eventually we'll get enough that you'll feel more comfortable with the language itself. So the idea of a function, and this is, sorry, I guess my sort of mental image of how functions work. I like to think of them like a factory. Maybe it's weird of me to think of it that way, but things are going into the factory and things come out of the factory. If I'm building cars in a factory, I have a bunch of parts that go in one door. The parts go down an assembly line, are built into a car, and the car comes out the other end. Now, keep in mind a couple little key points. First of all, functions, there's entire languages that are all they have in the language are functions. They don't even have variables. Uh, but a function has input, it has output, it does something in between, and that's it. That's the sort of the foundational concept behind a function. Um, but and the thing I wanted you to keep in mind is the input should change what happens with the function. It should be used in some way, and the output should be handled. It should be picked up. It should be used. So if numbers are coming in and numbers coming out the other end, you should be using those parts. It shouldn't be hard coded values. It shouldn't be anything else like that. The idea of a function is I will, much like the sine function in math, right? You have sine of 45. What is that value? Some number goes into the function, the sine function, and it spits out and a number gets spit out in the end. Right? There's functions all over mathematics. You've probably seen functions in other places as well, but you just may not have realized that there's something special about them. They are things they take in some kind of input and some kind of output pops at the other end. Much like putting ingredients into a recipe, you cook it, and then you have a meal that pops at the other end. That's sort of the mental process that I'm trying to impart on you guys. So let's look at some random function. I'm going to have a function called add. It will take in two inputs, val1 and val2. Why? Because they're not original names. So I'm going to take two values that are going to go into this function. Some magic is going to happen, and then at the end, I'm going to output a number. Ideally, that number is just going to be value 1 plus value 2. That's all I'm going to be doing in this case. Now, if nothing is going inside those parentheses, this thing right here, so this is one way of looking at it, right? I have val1, val2, I'll do the 2 down here. Things go in and stuff comes out. That's the way to look at this. There's an integer popping out the other end. It's the inverse of the image down. It's the mirror image of the image down here. Uh, the reason I won't like to think of it that way is that's it also is how we do something like sine, right? The sine function will look very similar to that. I will put sine of 45 and boop, out the front pops the answer to that. If I do the absolute value, so absolute value of instead of doing something else, so let's do the absolute value of -4. And I need to store that somewhere afterwards. So int x is equal to absolute value. This would be the same as saying int x is equal to the absolute value of -4 if you want to do math notation, right? But it's the same idea. I have a function that takes in some value, it spits out some other value, and you're catching that other value and storing it somewhere on the left hand side. That's how we were doing assignments beforehand, right? We had int a is equal to 2 or int b is equal to the variable a, right? You could say int x is equal to whatever the heck this value is. So x will be given the value 4. The absolute value of -4 become this thing will spit out 4. This whole function will spit out the value 4, and that value 4 will be stored in x. So, or that's what I would expect if I was writing this function, right? So it would be the exact same as the line below, which is I have x and I'm going to do the absolute value. I want to be very careful about how I'm saying this because I know it has confused some people in the past. We have some kind of function that takes an input, it spits out output, and it is so critically important to all of the rest of the stuff we're doing in this course that I want to make sure it's obvious what I'm trying to get at. Functions are everywhere in C. In fact, we've already used a function. Printf is a function. We've already seen one. We're going to see a lot more over time. But printf takes in some stuff, it spits out some, and it does something, right? Now, a function doesn't have to return a value. It could return void. So it also doesn't have to take in a parameter. It could also have void as a parameter. It doesn't. You can either have no input or no output. Both would be fine. There's a whole bunch of variants on how we can do this. And we've seen the main method or the main function, which doesn't take any, or the one we had didn't take anything as a parameter, and it returns an integer. Functions are extremely common, and just want to sort of, what you want is that the function does its job and you blindly just use it so that you're not having to figure out, oh, what does that do in this situation? So, uh, we're going to do a little bit of an exercise, but I want to look at some code first. So let's bail on this first. Let's look at my original function I had here, and I want to do. I said I was going to fix this. So my main function takes in no parameters, returns an integer. Why does it return an integer? Well, there's a philosophical point to this. It doesn't make any difference to the main method whether we return something or not. We could have a void there. That would be perfectly fine. So I could have this. That would be allowed, or it should be allowed. There you go. That's perfectly allowed. But if I might want to have it return something so that you can test if the program had some kind of error, some other function that is calling your function could test whether there was an error occurred, that some bad things happened. And if nothing bad happens, you return 0. Something like that. So it won't make any difference to your program whether you have an int here or void. It should make no difference. Other than if you were returning an integer, you better return the thing you're going to, some value. It has to pass back out an integer. Another way of looking at a function is like, maybe a game of catch, right? The ball comes to you, you catch it, and then you send it back. Now, you could be doing something to that ball when it comes to you and then you send it back, or someone passes you something and then you send it off to the next person. It's this idea that each of these parts, each of these functions does their job. It takes certain inputs, something comes out of it. If you're not using what comes out of it in the end, why are you doing anything at all? So if I have a function called average or average float and it returns a floating point number, if I'm not somehow catching and using that data, it's returning a value, it's returning a number. If I'm not using that value, why did I waste my time calling the function? Okay, so here is, I'll just quickly, there we go. Here is, I'm going to write two different functions here. And if you've done some functions before, you can try this out. If you haven't before, then you can either wait for me to show it or you can try it on your own and then we can go over the answer. Trying it on your own and then seeing the answer is the better approach, by the way. So this average float, the name of the function is called average float. It will take in 3 floating point numbers and it will return a floating point number. It will be the average of 3 floating point numbers. The average or the mean, by the way, is you add the three numbers up and you divide by 3 in this case. Eh, that's just how we're going to do it. Okay, we're also going to have an average integer, which takes in three integers and returns the average of the three integers. But that average is going to be an integer itself. Maybe you'll see what I'm trying to get at here with this. So if I have three integers and I take the average of them and I'm returning an integer, what's going to happen to my numbers if they're not evenly divisible, if it's not evenly divisible? So we're going to look at these values one after the other. So I wouldn't mind, I think it would be a good idea to try writing average int, try writing average float. Well, we pause the video. Try writing average int, try writing average float in some kind of main method calling average int, and notice we need to store the value for average int after we're done with it, right? We need to actually use or store whatever this thing spits out, because otherwise it's just going to go away. If I have a factory that produces cars and the cars just fall off into a ravine afterwards, you might as well not have a factory at all, right? It's just you're piling up a bunch of broken cars at the end of a ravine. You need to take the cars and ship them off somewhere. Same thing here. If I have a function and it's making a number, it's doing some calculations, you need to store that number somewhere. So, take a pause. We're going to go over the answer for the average float and average int. And after that, we're going to try something out for the quiz. I'm not going to show you average int running, let's say. Okay. Hopefully you paused. Okay, let's try this. So I'm going to make a function called average int. I can finally use my prototypes. I'm going to make some prototypes here. This is just a stubby, I like to call them. It is, sorry, I gotta sneeze. Sorry. So I have average int, and it's going to take in three integers: int val1, int val2, int val3. And if I can spell val correctly, I'd be all fine. I'm also going to be lazy and just copy and paste and change things around. It's because I want floating point numbers for these. Also, let me point out another weird thing about this. So not average int is going to be average float, I think is what I wanted to call it. Okay. Notice I have variables val1 here and val1 here. They are different things. And you'd say, well, don't you have a collision? Don't you have, which val am I talking about? If I call average float, this val, we'll look at what the heck happens with val1 and these vals. I will make a brand new variable, floating point variable called val1. It will only exist while this function is running, and then it will immediately be destroyed. So these are, I'm making three new variables, val1, val2, val3. They live and die only within that function. We'll see it in action, hopefully, and it'll make a bit more sense. So those values will live and die only within the average float function. So here is what this is what my stubbies are doing. I am going to, so let me do some things here. All right, and let me just put some fake numbers in here. The purely fake numbers. Return 0.0f. Okay. That is my way of saying it is a floating point number. That's what the f is for. And notice it's 0.0. I could just return 0, but it's going to say, oh, that's an integer. Okay, let's look at what's going on here. A prototype, what we have up here, is just saying, by the way, at some point in time, I'm going to make some function called average integer. You can know that this function average integer is eventually going to be defined. So I can use average integer in main, right down here. It will go, hey, where is that located? Oh, it's located down here, and we'll go and find it. This is effectively like a table of contents. It's a IOU function named average integer. So you better define it later on. And if I don't get the function called average integer that you promised me. This is an IOU. IOUs, right? These are a bunch of IOUs. I will owe you one. There is going to be two functions called average integer and average float that will eventually be defined. So that main, if you want to call something called average integer or average float, we promise you that it will eventually be defined. That's what that's for. It's an IOU. I owe you a function called average int, and if I don't deliver, if you as the programmer don't deliver with a function named average integer, you're going to get an error. But it allows main to know that there will be a function called average integer. It can look up and say, hey, there's going to be a function called average integer, and we will figure out how to hook these things up. Okay, so that's what a prototype is for. It's an IOU for later function. I want to let's do the average float. Okay, so I could do this one of two ways, but I'm going to say float sum is equal to val1 plus val2, if I could type, plus val3. I'm making three different variables, val1, val2, val3. Their values, because they're an input parameter, those new variables their values are going to be set. They're going to be immediately set to a particular value. The next line of my code is I am going to add the three floating point numbers together and store it in a brand new variable called sum. So I make these variables, they have a particular value. I'm going to add those three up, put it into a variable called sum, and then what I want to do is I don't want to return sum. I could return sum, but return sum divided by 3.0f, a floating point value for 3. Why not just 3? Well, we could actually try that. We can actually look at that. But 3 is an integer, correct? And therefore, if I do an integer division with a floating point number, I don't know what happens. Actually, I do know what happens. We can see what will happen. So let's do this. Float sum1 is equal to, and then I'm going to call average float. So this is me calling this function. I'm going to call it on 2f, 0.3f, 0.1f. I want three numbers that I'm pretty sure I know what the average is going to be. What I should get when I do these three numbers is it should be 0.2. There's one number above, one number below, one number at the average. I should get 0.2 as the average. So someone should be equal to sum1 equal to 0.2 f. Alright, that's what I expect. I'm making a hypothesis. I'm expecting when I add these three floating point numbers together, 0.1, 0.2, and 0.3, if I add them together and divide by 3, 3.0, I should get sum1. Alright, so let's compile this. Let's save it. Let's build it. Control-Shift-B is the fast form of it. Right, okay. And I'm going to do something crazy. I'm going to do something called a breakpoint. I'm going to just click on this gray bar on the side here, or I could also click, well, in my case, function F9, but F9, and I can put a breakpoint down there. This is going to stop my program when it gets to this line. So I put a stop sign on this line to see what's going to happen. Okay, the program stopped. I have a little arrow here. It's pointing to what line I'm on. Okay, just to let you know how to do this, so I can go into this, so I can go to my debug tools, and I can step over, step into, or step out. Step into would be I go into my function, average float. Step over is I'm just going to go to the next line. Step out is if I'm in a function, I can go out of my function. I'm going to do a step, let's do a step into actually, also F11. And I'm going to go down a couple. I'm going to use a hotkey in this case. So what I expect is so let's look at my values here. Val1 is equal to 0.2 with a bunch of 3's at the end. The value 2 is equal to 0.3. Wait, what? And value 3 is equal to 0.1. If I go back up here, notice 0.2, 0.3, 0.1. Notice 0.1 as a floating point number. There's some weird precision things at the end. That's one of the problems I always have with doubles and floating point numbers. The number gets shifted a little, just enough to make it hard to reason about. So this is 0.2, 0.3, 0.1. And when I go down here, notice the order remains 0.2, 0.3, 0.1. I made brand new variables, val1, val2, val3, which are given the values, the three different values with how the function was called. So val1 is 0.2, 0.3, 0.1. Right. If I sum those numbers up, what do I get? Let's see if I can actually see what my computer is doing. Okay, so if I sum them up, I should get 0.6, the sum of those three numbers. You can see it down here on that line, or I can float my mouse over top of it. It's going to be 0.6. 0.6 divided by 3 should give me, I'll do one step further, and my return value, I'm not going to see my return value until I pop out one level. So I'm going to go back to, it's going to go one more step, it's going to go back to my function that the call my main method. Let's look at sum1. Sum1 is equal to 0.2. Okay, that's exactly what we wanted, right? The average of 0.2, 0.3, and 0.1 is 0.2. Great. Let's stop my program. I can press the stop button here and just stop the whole thing. Or I could just continue and let my program terminate on its own. So let's have it terminate on its own. All right. Let's go down to back down to my average float, and let's get rid of, just because I'm curious, let's get rid of that point. Let's just divide it by 3. All right. Let's rebuild it. Hopefully it's going to work. All right. Let's run my program again. It's going to stop there again. I'm going to take a step over now. I don't need to go into it. I'm going to step over. I'm expecting it to say 0.2, right? That's what we expected for the average. So let's see. Actually, that's surprising. It actually worked. Oh, because it's going to floating point number at it. Okay. Depending on what kind of number you're dealing with, things can get a little hairy. That I will not get integer arithmetic if I try and we're going to see cases where I don't get the integer arithmetic that I expected. So by having a integer and a floating point number, I'm not always sure what it's going to do. In this case, it gives me a floating point number and returns it. There are times when it may not. So if I added 3 integers divided by 3 and then turned that into a floating point number, it would not work. But it depends on how you want to code your thing. I would actually always divide by 3.0 just to make sure I know I'm only dealing with floating point numbers. Let's do another example. Let's do the average int. So average int is going to look exactly like the last one. I'm going to stop this thing here. Average int is going to look exactly like the last one. The only difference is going to be, and I'm going to put this back to 3.0f. The only difference is going to be that I am going to have integers. The sum is going to be an integer as well. The value, and then I'm going to sum divided by 3, and I'm going to return that, and we could see what the number is going to be. I would strongly recommend trying to write this and see, because that's what the quiz is actually going to be testing. What would you expect to see if I have, so then we also have to do this, so let's do average integer, I call it sum2, average int, and I'm going to say 2, it can't have 0.2, 0.3 or anything, so 2, 3, 1. Alright. I'm not sure if this is going to cause any kind of particular problems. This actually should work just fine. So we won't see anything weird going on with this one. And beyond that, I'm going to do a couple of one other thing. Instead of a breakpoint, so I could have done this whole breakpoint thing again, or I could move my breakpoint down to get rid of the old one. Instead of a breakpoint, what I could do is, and it should be F, I do believe, unless it's a double. I'd have to digits for double, so it should be F. And I'm going to use I for integer. I could also use D for double, or for digit. Okay, and that's going to be sum1, sum2. All right. What the heck did I just do there? Okay, this is going to print things to the screen. That's all printf does. It takes whatever is in here, especially that first parameter, and outputs it to the screen. That's what this hello world thing is doing. This is what the hello world here was doing. It is, I'm going to put the message hello world and a new line. That's what this /n is, a new line, and I'm going to print it onto the screen. I'm going to take how are you, and a /n, and I'm going to print it onto the screen. I'm going to write the words, the text, the two sums are this and this, new line, and print it to the screen. And this is where the quirky thing about printf is. It's going to say, by the way, what the heck is this thing? Oh, it's going to be the first parameter. I'm going to, whatever this first parameter is, I'm going to stick it in here on that %f. And whatever the second parameter here is, in order, right? So it's whatever the second parameter here is, I'm going to put this right in this position for the %I. Let's run this and see it in action. Okay, so I calculated two different numbers. I am doing a couple other print statements. I don't even need to do the breakpoint anymore, so let's get rid of that. And this thing is going to print out the message, the two sums are, and then it's going to give me sum1 and sum2. Let's see it in action. Hopefully it's going to work just fine. Okay, the two sums are 0.2 and 2. Great. That's exactly what I expect. This is my set. Well, these are my three printf statements that I made. This is me taking one number, shoving it in my message, taking the next number, shoving it in my message. That's what this printf statement is doing. Notice I use my functions to calculate this, I use my function to calculate this, and I store what the results are. Because I don't want to, do something and not, record that value. If I didn't store it somewhere, it's going to do the calculation and just throw away the value. And I don't want that. I need to store it somewhere. I store it in one of these variables. All right. So here is average integer. I should also have little comments, and I should have a comment block and stuff. Here is average float. It takes in three values. It figures out the average floating point value. This takes in three integers as parameters. Whatever the values are, 2, 3, 1, I will make three new variables, val1, val2, val3, give them the values 2, 3, and 1, and they get destroyed whenever this function is done. When this function is done, val1, val2, and val3s all get destroyed. They just get given back to the system. And the function itself returns some integer. That's what this thing is doing. It's returning whatever that sum is divided by 3. So 3, 2, and 1 added together, so 6, divided by 3, 2. So I'm going to return the value 2. And that's what I returned out of my function. Functions allow me to pass information to somewhere else to do the calculation for me. If I pass in a whole lot of numbers to a function, it can calculate the average for me and just return the value. If you have not seen a function before, if you've ever seen Excel actually, then you've seen functions. You've seen lots of functions. They're everywhere in Excel. You have the average, you pass in some value, like the cells that you're going to be using, calculate the average for, and it spits out some value, puts that value into the cell. You'll see them throughout. Like, I strongly encourage just walk around and look for functions in your daily life. There are more than you might imagine. Okay, so the quiz itself is here's what the average is going to. I could run this, I could run this, and then I'm going to output the average value for the average int. What, uh, and so the question is, what does this printf statement mean, or what is going wrong with this printf statement? You're going to see something weird when I try and run this. If I try and run this printf statement with 327, 292, and 400, I can go back to my actual code. Uh, 397, 492, and 200, I do believe. And I run my code, it's going to give me a weird value, or it should give me a weird value. If you try and do the average of those numbers right now, you can also figure out what's going on. Okay, so I don't want to permanently store those. But what the heck happened there? And can you deduce what the problem with some of this is? Okay, the printf statement means I will take this message here. Every time I have a percent something or other, I will get one of the other values afterwards, average int for example, the next parameter, the next thing in my function, the next field in this function call. I will take this average integer, I will shove it in wherever that percentage I is, and then I will print this entire thing out to the screen. Printf itself is a function. Okay, so here's the main method, which is a function. And so I want to just start that. So here's the main method, which is a function. Notice I can have a comment like this, double slash. This is a block comment after that. This slash star star slash. This gives me a block of text that I can write, and it can cover multiple lines. It's wherever I started it with a star a slash star, and I end it with I start it with a slash star, and I end it with a star slash. Here's my printf statement. Let's do one other thing, because what is this stdio crap doing? Let's have a look. So let's go to my code. If you ever wonder what the heck it does, just get rid of it. Find out what happens. All right, I've commented out standard IO, the IO stream, or standard IO. Let's do standard IO. There we go. And hopefully, let's just make sure it's going to work properly. I think it might be .h. There we go. Now let's try and compile my code. So I'm going to build it. I'm going to build my solution. And a bunch of crap happens. In fact, a whole bunch of stuff broke. What? I don't know where to go. Okay, so I have a printf statement, identifier not found. What? Printf statement, identifier not found. What is going on? So what is going on? This says include all the information for the standard input and output IO, standard input and output libraries. So if you want to output things to the screen, or if you want to take input from the users, you need to include this. Otherwise, it has no idea what the hell printf is. It's not a built-in function. It's from standard IO. Printf is a function somebody else wrote that you can use because you included their work by calling this include statement. That's the other part. So we have our include statements and our headers, the stuff that we have to build for, take in from other people, the other people's libraries. We have our prototypes at the beginning, which is the functions I will eventually define. We then put in our main method, which is the start and end of our entire program. I start here, I end there, that's it. But I can walk down here, jump over to this other function, jump back, do some more, jump over to this function, jump back. In fact, let's do that. I'm going to do this. And let's do call it sum3 for just no reason. Let's compile it. Let's put a breakpoint here. What do I expect to happen? what I expect my code to do is it's going to walk down my main method. It's going to go to the first function call. It's going to go to this line here. It's going to jump on down over here. It's going to calculate a bunch of stuff. It's going to go right back to this line up here again. Next line, it will do the average integer. Call that, jump down to that function. Do this. Jump back up again. It keeps on jumping around, going from function to function. It goes to the function, does its calculation, and comes back. So let's change this around to 0.1, 0.1, and 0.1. Let's say. I'll have different values here. So let's actually see this in action. I'm going to run my code and see what we get. Okay, let me take a step into my function. It's going to call that function. It's going to jump to that function. So I will jump down to average float. It automatically does this. That's the next step of my execution of my code. I will then calculate some stuff. I will jump back up again because when average float is done, it passes a value to some 1. Next, I'm going to go jump into average integer. Take a step, take a step. It's going to return whatever the sum divided by 3 is, which then gets stored in sum2. It's then going to jump into average float again. Notice average float's inputs were 0.1, 0.1, 0.1 in that last time, right? It's up here. I'm in this function right now, this one right here. The 3 values are 0.1, 0.1, 0.1. Let's see what my values are. Value 1 is 0.1, value 2 is 0.1, value 3 is 0.1. I have these variables. They have different values than they had before. Last time it was 0.3, 0.1, and 0.2. Now they're different values because I'm calling the function again. These values, it changes depending on who calls the function. Okay, so next step, I'm going to do the sum of the 3 things, 0.3 divided by 3, so it should give me 0.1. So sum 3, if I hover over it, it says sum 3 is equal to 0.1, which is what I expect. Then I do the rest of my function, printf statement, printf statement, printf statement, get down to the return 0, and I'm done my entire program. There's no more program to go. I could actually just keep on trying to keep on going, but that's it. That's the end of my program. It starts at the beginning of main, it ends at the end of main. That's it. There's nothing else there, but it can call another function and the other function does stuff. And it can call another function and that other function does stuff. You are bouncing around a lot to other functions, but the main method, the start and the end of the program, is just defined by the main method. Okay. So let's have a quick look at what we're looking at so far. We'll go over this again, also slowly, very very soon. Okay, so we had a main method, we had prototypes in there, we have an include statement at the front because otherwise we don't know what the heck printf is. And if we have functions that we define them below the main, right? We have a prototype up here and we can define it below the main. Here's a comment, here's an include statement, here is a preprocessor directive. We're going to get to that much later in the term. But essentially there are ways of saying, rather than making a variable, rather than doing things certain ways, it's just saying everywhere you see the word MSG, plop in the words, hello, plop in this text, hello world /n. Everywhere you just blindly replace it. It is like a macro for in other places. That's actually what this include is also doing. Here's my actual code. It's my main method. I have a printf statement which is going to put out hello world. I have an integer I which is equal to 0. I'm going to return whatever I is with the value 0. And that's all my function does. So we've already coded average int and average float, so we won't need to do that again. But just to be clear what's happening, my functions you can pass information to the function, it does some calculations, and then it passes information back out. The important thing about a function is that functions pass around values. They don't pass around variables. The number, the value of those variables are passed around, but the variable itself does not move at all. You just pass values around. Okay. Uh, and by the way, just a reminder: a C program ends when you reach at the end of the main, which is what we've always had so far. If I write the word return in the main, that just bails out. Return says get out of this function right now. Uh, and then there's sometimes you can call an exit call in the main method or anywhere actually in the code, and that will just kill your program right there. That is the in case of fire, break glass approach. Just calling exit, it just kills everything. Not the way you want to end your program. Okay. Um, Notice what we did here with our other program. We could press play, the play button, and that'll start in debugging mode. That allows us to see breakpoints. That allows us to look at the data. We can also start without debugging information, so we can't necessarily trace what's going on in our program. It doesn't, but the code will be faster. So it'll be faster. It'll actually pause at the end so you can see what the values are for your output window, but it's not the main. I've just been pressing the play button the entire time. So press the play button and go see what your code does. And if you're not sure what your code does, press the play button and find out, right? Compile your code. So we need to always do two steps, right? We do two steps. We do compile, or build, right? We build our solution, our executable. That's one step. That goes from text to bytecode, text to machine code. And then when you run it, we just run the machine code. So if we go back to, I'll show this again in a second. So this is just the very, very, very first pass of C syntax. We will take this a lot more slowly soon. The C build cycle builds up. So we're going to look at preprocessor directives later on in the term. But we build, we compile, we link everything up. That is this whole process to go from text that you wrote to instructions for the machine. After that, then we can run the instructions for the machine. So we looked at making a new project in VCC, Visual C++. We looked at compilation, and we looked at running code. We're going to look at C syntax very soon, but just a quick reminder, for this project, I will build my solution, and then I'll press play. The issue is this. What happens if I don't build every single time? Now, you could do this. You can build and execute at the same time. A lot of people try and do that. I recommend against doing that, but people do it anyways. So, what the heck would building and running your code at the same time do? I think it's F5, start debugging, start without debugging. I'm just trying to see what the actual run and don't even compile again does. If I don't build each time, what's going to happen? So let's say I'm going to do this. Return 0. I'm going to have this instead of this line. I'm going to return 0. So average integer is going to give me garbage. It's going to give me a 0 every single time. That's what this thing is going to do. Who cares about the calculations? Who cares about this thing? It's just going to return 0 each and every time. That's what this thing should do, right? I don't have it doing the average anymore. It just returns 0. So let's run my code and see what happens. And I'm going to get rid of this breakpoint because I don't need it anymore, and continue. So, and the value is 0. Okay, actually worked better than I thought. Let's see. That was really surprising, actually. You caught me with my pants down on this one. So essentially what I was expecting and what should have happened. What didn't happen, but should have happened. Let's do this, or let's actually do this. So I'm going to make sure that this breaks. Great, it breaks. It's not working. I removed a semicolon, common error. It broke. Let's try it a different way. Let's just run my code now. And do not show this dialog again. If you click the do not show this dialog again, it should be fun. Would you like to continue last successful build? Yes. So a lot of people do this. I'm sick of this pop-up window, and then they click yes, and they never see that dialog again. And what do you think happens? Okay, oh, unable to open the file. Let's see it again. Oh, that's surprising. Um, wow, this is catching me in all sorts of different ways. Here's what ends up happening for a lot of people, and I cannot reproduce the issue. What people are actually end up doing a lot of the time is they write their code and they build and execute. They build and run the code at the exact same time. They just do it all in one step. But their code has an error in it. If their code has an error in it and they do that, and they have this turn off the pop-up warning you about the compiler error, what happens is that you get what you end up seeing on the screen is the wrong value. It's not the it's not the text that you want. So let's compile it again. Let's get rid of this and let's get rid of that semicolon. Let's try one more time, but I'm not sure it's going to work. It's really not working for me. I have so many students actually do this. This is why I never get into this habit myself. That's why I can't reproduce it very easily. It's There are ways of making it so that you do not build your code each and every time. Then you go to run the code, but since you had compile errors, nothing the new executable hasn't been built. You are still looking at an old version of your file, an old version of your executable file. So you built it successfully 4 hours ago. You do a bunch of stuff that breaks your build so that things don't compile anymore. You then go and test your code, but your code is what you're testing is the code from 4 hours ago. And you're testing the code from 4 hours ago, and for some reason, you don't see anything wrong with your code, or nothing you do changes your code, and it's weird. And the reason for that is because you're still looking at code from 4 hours ago. I always recommend doing this as a two-step process. I will always build my code just to make sure, hey, look, I have a syntax error. What do you know? And so if I try to run my code, let's see if I can, I want to reproduce this bug. No, I cannot reproduce it. Okay, I have a syntax error. If I have a syntax error, I need to fix it, build it, and make sure it says one successful, zero failed. Okay, I need to say it was successfully built. Once I have that, then I will see the difference. And if I don't have it successfully built, I'm looking at old code from before. And that it bites at least 20 students every single term. So please build, then execute as two separate steps. Okay, with that being said, I'm going to take my leave of you guys. We're going to get to arithmetic soon. We're going to look at printf statements in a lot more detail. And then we're going to look at functions again. But I wanted to get you that first pass at functions because they're so important. We will see all of these concepts again. But I wanted to have a multiple pass to hopefully let it sink in a bit more. All right. Thanks, everyone. I will talk to you soon.